Welcome everyone, this is Harnessing the Wind, a Do Something Reporter project by Nicole Shiner for the class BB2201. My goal was to produce energy using a mini wind turbine. So let's give you some background information on wind turbines. Here are some numbers. A turbine can produce an average of 6 million kilowatt hours in a year, which can power around 332 homes. The price of this energy is actually cheaper than others at around 5.5 cents per kilowatt hour, but may get even cheaper in the future. Now compared to other energy, it's around 12 cents per kilowatt hour. And some benefits of wind power: it's a clean renewable resource with zero emissions once installed. There's no air pollution or water. So that means no oil leakages, no acid rain. Plus, the inexhaustible supply of wind provides the US with an independent source of energy if we're trying to move away from foreign oil. There's also multiple building locations: rural homes, such as in your backyard if you wanted to, farms where we're growing crops, or even you can stick it in the ocean. And trust me, there's a lot of space in the ocean. Let's put wind energy in the perspective of the US. Over 190 million megawatt hours were produced by wind in 2015, which can supply about 17.5 million homes. But that's only 4.7% of the electricity generated in the US. Now, we are doing a lot better than solar, but that's still nothing. Though predictions state that wind power will generate 20% of America's electricity by 2030. The US wind sector also is a great source of jobs for Americans. And also, wind energy prevented 159 million metric tons of CO2 being emitted if that energy was produced by fossil fuel plants. And as can be seen by this demographic over here, Iowa is actually the lead producer in wind energy. Slightly over 30% of Iowa's energy comes from wind. And Minnesota has 17% of our energy from wind. Good job, us. When it comes to wind in other parts of the world, I want to talk about Denmark. I am so proud of Denmark. Denmark has the highest proportion of wind power in the world, supplying 42% of its energy from wind. It gets even better though. On February 22nd, 2017, wind power generated enough energy to supply Denmark for an entire day. Oh my goodness, that was over 10 million average homes of electricity. I have no words. Then this little chart on the side shows actually how globally the installed wind capacity is greatly increasing, with China in the lead, then the EU, and finally United States. Now for the exciting part of actually building the project. I went to 3 different stores to get all my supplies: Home Depot, Jerry's Hardware, and Axeman Surplus. I got 2 different DC motors, a 3-volt and 9-volt, to test how different motors affect the amount of energy produced. Then a multimeter will test how much electricity was actually produced, and everything will be connected through wires and alligator clips. An assortment of LED lights was bought to see if I could light them. The large sheet of foam core will be used to build the base of the turbines, as well as a set of blades. The plastic lids and bamboo skewers are also for making the blades. Finally, the hot glue, masking tape, and super glue will help attach everything, and the X-Acto knife will be used for cutting. Now to build. After planning how my turbine was going to look, I sketched out all the pieces on the foam core, cut everything, and then assembled the base. My design started off with 2 identical trapezoidal pieces with a hole near the top to fit the DC motor for the front and backs of my turbines. I then cut and attached the sides and top of my turbine. I slid the DC motor into place and also glued it. Then I redid all the cutting and gluing a second time for the other DC motor. Once I had both the turbine bases done, I attached the wires to the backs of the motor, which can be seen in the top third picture. I made one set of blades using plastic lids and the second set using foam core, since I had run out of lids at that point. I cut both lids into triangular shapes and put a bamboo skewer through them. This is what the first picture is showing me doing, and then I attached each pair of blades to a foam core circle and then glued the circle to the front of the DC motor. This is where the first issues cropped up because both sets of tilted blades kept hitting the bases of the turbines. I had to remove each set of blades and keep extending the blades out further with more foam core through trial and error. Finally, once I was done, I glued both turbines down onto the same foam core sheet. And then lastly, I prepped the LED lights by arranging them in a row and wrapping the spare wires around each prong in a line. Now on to the results, and actually before I discuss the results I got, I wanted to show you a tiny clip I had of the wind turbine in action. So here it is. So on to the results. I actually tested the 3-volt and 9-volt DC motors with a fan that actually had 3 different speeds, and the fan levels correspond with faster speeds and therefore higher amount of energy produced. So starting with the 3-volt, it produced 216 millivolts, then 320 millivolts, and then 475 millivolts. And then when it came to the 9-volt motor, which was spinning, it was spinning a lot faster. And actually the multimeter was weird. It switched units and decimal places, so I just recorded what it said. It was 0.361 volts. Then fan level 2 had 0.492 volts, and then fan level 3 at 0.627 volts, I think, unless it was actually 6 volts and 4 volts and 3 volts. The multimeter showed it really weird. For the finale, I attached the wind turbines to LED lights, and they wouldn't light up. It wouldn't light up if it was both turbines or one turbine, or if I singled out the LED lights. Maybe the LED lights were duds. It was a real bummer. And now we're at the end of everything. Now, as can be shown by my mini wind turbine project, it proves that wind can produce energy. Wind is an excellent renewable resource, and as can also be seen by the energy generated by my turbines, increasing with wind speed, the amount of energy produced can vary from day to day, but is still reliable. Like with Denmark, how I discussed in my background section, normally their wind turbines cover 42% of their energy, but on an extremely windy day, the whole country's energy was covered, and that's phenomenal. I have high hopes for this industry. And basically, until the wind stops blowing, we have a clean and cheap alternative to fossil fuel electricity production. Have a nice day, everyone.